Hello. In this video tutorial, I am going to solder an audio XLR connector onto this microphone cable. So I've already stripped my wire back and removed my foil shield and twisted the shield cables together. Now I want to look at the contents of the package from the XLR connector. This is the connector, right? The connector body, and this slides in from the back, like so. Once we assemble it, this assembly fits behind it, and then finally this will screw on the back. As this screws on, it will squeeze these little jaws together and crimp down on the cable to provide a strain relief. Now what we want to have happen is for the little jaws to crimp on the outside of the jacket, not to try and crimp on the little wires on the inside. That's important as we try and determine how much of this wire to go up inside of the connector. Now, everything can be installed from the front except for the little piece that screws on at the end. So what we should do is go ahead and make sure that we install that over the end of the microphone cable before we start assembling this connector. Now I want to determine how much wire I need to have exposed, how much of the conductors I need to have exposed. So if I want the little jaws to be able to grab that outer conductor, and I line that up with that, it looks like it's just about as long as this outer shield. So I'm going to go ahead and cut my wires right about here. There we go. So now each of them are at the appropriate length to be able to do what I need them to do. I'm going to go back to my silver one and I'm going to twist it a little bit more just to make sure that everything stays together. And then I'm going to go to my red wire and line it up so that I can strip back the outer insulation of that. And I just need a little bit. I just need about 1/8 of an inch or so. I didn't quite get a good strip on that. There it is. So now I go to my next one, my black one, and again about 1/8 of an inch. And now I'm going to give those a little twist, always twisting in the clockwise direction, which is the natural lay of the strands. So I'm twisting away and twisting away. So now I'm going to just put it in my little solder vise just so I can hold it all in place while I do this. I will introduce you now to solder. This solder comes from Radio Shack, which may or may not be defunct now. It's primarily made of tin. It has a little bit of lead in it, and it melts, depending on the composition, of somewhere between 800 and 1200 degrees, which means that the soldering iron is very hot. This iron has a temperature control. I'm running pretty hot, right? And if I touch the solder to the end, it will melt instantly. You can see the little glob that's on the end. At the solder station is a little piece of brass where you can wipe extra solder off and keep your tip nice and clean. What I want to do now is a process known as tinning. And what it does is it just puts a little bit of solder on the end of each one of the conductors. So I'm going to just get a little ball on the end of the soldering iron, hold it underneath of the wire, and then feed a little solder onto each one of the wires. So now onto the black one, and I'm just coming up underneath of it. And all I want to do is just get a little bit of solder to hold it all together. And now the shield, solder a little bit on there just so that it all stays together. Okay, so that's pretty good. Now what I want to do is go ahead and look at my connector so that I put the wires on the right terminals, on the correct terminals. And if I'll look down at the end of each one of these, and it is printed on both sides, but what I will find is that this pin here is number 2. The pin at the bottom of the 3, this is pin 3. And then to the left is pin number 1. Pin 1, pin 2, and pin 3. Now I want to orient this connector in my little alligator clip here such that I can get to the solder cups. If you'll look on each one of these, you'll see there's a little cup. It's cut out. It's like a tube, and then half of it is cut away to allow the wire to lay in there. Now if I look at this, pin number 2 is down at the bottom. I always have to double and triple check this. So from the back, this is pin 2, pin 1, and then the top one is pin 3. So I'm just going to insert that into my little alligator clip vise. Again, pin 2, pin 1, and then the top one is pin 3. So now I'm going to align my wires. So I know that my shield is going to go into pin 1. The wire that has no insulation on it goes into pin 1. I also know that in pin 2, this one over here, is going to take the red wire. It's going to take the positive. And then the black wire goes to pin 3. So let's just go ahead and bend these around a little bit so that they all line up like what they're supposed to line up like when we have our final assembly. Yeah, something like that is looking pretty good. We're getting there. Getting there. Now I have my piece that needs to go on the back. That's my strain relief. And now I'm just going to clip this in to my alligator clip back here. And then I'm going to line these wires up. And I'm going to line all 3 of them so that they'll just sit inside that solder cup. My black one is not making great contact. Okay, so now I have everybody lined up and it looks pretty good. Looks pretty good. It looks like I'm going to make okay contact on everybody. My shield just popped out. Again, getting it all lined up. That's great. So now I can go ahead and make my solder connections. So what I want to do is take my iron. I'm going to untangle myself a little bit. And again, be mindful that this iron is very hot. And what I'll do is I'll start with the shield and I'll put just a little solder on the end. By putting solder on the end of the iron, it helps with the heat transfer. It helps to heat everything up. And I'm going to heat that wire and that connection all at the same time and then feed just a little bit of solder on there until it flows across that connection. Let it cool. Sometimes you even blow on it. And then I'll come up and do this top one. I'll do the same thing. I'm just putting a little bit on the iron and I'm heating that entire connection up, the wire and the cup, until I get a little flow, and then I can remove. More solder is not better. You only need to use what you need to use to fill the cup. Having a big ball of solder on the outside of a connection is not a sure sign of a good connection. And I feed a little solder in there, and then there we have it. That is the solder connection for an XLR. Now we'll finish assembly. This connector is hot now. You do want to be careful. Solder should be shiny when it's done. If it has a milky or cloudy color to it, then that means that you got a cold solder joint which it wiggled. Somehow it moved while it was cooling. You always want to hold the wire absolutely still when you solder it, because if you wiggle it back and forth, it makes for a weak connection. Now, our little strain relief, our cable grip, They were nice enough to put a slit in it, and so it simply slips over the outside of the jacket. It has a groove there, that notch that's cut out, and that aligns with this piece of silver right here. Holding all of that in place, we can see that my little cable grips are going to squeeze firmly onto the end of the cable. And now I can come here. The threaded side will go back to this threaded side, and I have a notch right there. And that notch will align with that piece of silver. So if I just slide it in, that should go right up on there. I may have to twist it around a little bit. I'm not holding this so well. There it goes. And so now the entire assembly slides all the way until it's all the way up inside. The cable grip is all the way on the inside. And then I can slide this strain relief over the top of it, and I start the threads, and you'll hear it click. And you just tighten that down, and that squeezes on those little jaws and holds that cable connection tight. That's how you solder an XLR connector. Thanks so much for watching.